Okay, second last video of chapter 4.4, energy in reactions. In this video, I'd like to go through this thing here. Energy calculation, enthalpy changes to be exact. So what you're looking at in here, actually, this one, yeah. Is that energy calculation. Now, if you are driving a car, you will be using combustion reaction because cars have combustion engines, most of the cars anyway. I'm just making this up, but if you have 1 liter, and let's say that with that 1 liter of petrol, you can travel 14 kilometers. So that's the energy consumption there, 1 liter, 14 kilometers. What do you expect if you had 2 liters of petrol? Well, hopefully you're thinking that, oh, you should be able to travel double the distance. So in this case, 28 kilometers. Now, heat or kinetic energy, or released or absorbed, is calculated with number of specific mole of the reaction. Number of mole that's required in the specific reaction. So in this case, well, 1 liter or 2 liter of, well, let's say the octane is what was used. You can convert that into mole, and using molar enthalpy of reaction, and if you multiply that, should be able to get the Q, the heat that's being released by the reaction or absorbed, depending on what reaction you are looking at. Now that can be written as Q. So remember we were talking about Q before. This is another way of finding a Q. In kilojoules, if it's in kilojoules, sorry, that you want to find out, number of moles times by delta H, which also need to be in kilojoules per mole. Hope the units make sense. So when the molar enthalpy change is given, delta H that is, the quality of heat energy change can be calculated. That's what you saw just then. Q, kilojoules, equals to number of moles times by delta H, which is in kilojoules per mole. And here are details. So I might want to pause and copy that down. Now, one important thing that you want to note is that this formula doesn't rely on temperature change of water, like what we did with previous formulae. Delta H equals to MC delta T, or Q equals to MC delta T. So I should have started that. Q equals MC delta T, because remember, mass is relying on, the M in that first formula that you have had measures the temperature of water that changes, and mass of water that you are having in the calorimeter was quite a big part of the equation, wasn't it? Oops. All right. But yeah, in this equation, you don't rely on the temperature of being able to measure the temperature of water. This formula lets you calculate that heat given if you knew the delta H of the substance already. Now, second last thing that you need to consider is this, whether you are able to use this formula, like that's what's written at the top of the table there. Q equals to MC delta T. Q equals M delta H, it's just been covered, as well as delta H equals to MC delta T and 1000 N. Now, hope you notice that if you combine the first two, so Q equals MC delta T and Q equals N delta H, and cancel out Q because they equal to each other, you can make that into the last formula, delta H equals to MC delta T over N. Okay? But you're dividing that by 1000 because delta H is in kilojoules. One thing that you need to be able to do from this formula is that you need to be able to rearrange them and find what you want to find out from those formula. Now, Q can be found with those two already. There's no Q in the third formula, so let's move on to delta H. Now, delta H can be found from the second formula. Hopefully, sorry, a third formula there already has delta H in it. The second one can be rearranged into delta Q equals to something. So Q over N, that is heat over number of moles. Delta T is going to be a very similar thing. The first one, delta T, can be made into delta T equals Q over MC. And the last one can be made into looking like that. Delta T equals to 1000 N delta H over MC this time around. N, you can find N from the second formula there. N equals to Q over delta H, as well as the third formula that can be made into MC delta T and 1000 H delta H. Finally, M. You can find M from the first equation, like so, and for the last one as well. You need to be able to rearrange those three formula at the top, depending on the context that you are given or in the test condition, because, well, that's mathematics that you can apply to chemistry.